Okay, let's look at this grade 11 question on Newton's laws from November 2018. It says a box with a mass of 45 kilograms is pulled with a force of 40 newtons at an angle of 50 degrees to the horizontal. The box moves at a constant velocity. Okay, this constant velocity is one of our telling words, because the moment we see constant velocity, we know there is no net force, okay, because an object only accelerates if there's a net force. So mass times acceleration is going to be 0. So that is our first clue that how we're going to help solve this question. Then it says define the term kinetic frictional force. Well, that's the force that opposes the motion of a moving object relative to a surface. Okay. Now it says to you, state Newton's first law of motion in words, and that's a body will remain in its state of rest or motion at a constant velocity unless a non-zero or resultant force acts on it. Now it says to you, calculate the magnitude of the horizontal component of the applied force. So if we have a look at the applied force here, we know that this force is 90 newtons and it is acting at an angle of 50 degrees to the horizontal. Okay, so what is the x component? Remember, if you have this force, you can break it up into two smaller forces that are a fraction of the original force, and they will be at 90 degrees to each other. Okay, so the first force is on the horizontal plane, so this is FAX, and this one is FAY. Now remember, we can always turn any force into a triangle. So if I take this FAY force and I move it over here, okay, let's rub out this FAX and the FAY over here and then put them somewhere where it makes more sense. Look, here is the X component and here is the Y component, and I've made a closed vector triangle. If I look now, my applied force is now the hypotenuse of a triangle. My vertical force is now the opposite of a right angled triangle, and my X force is the adjacent of a triangle. Okay, so if we now want to deal with this force, if I want to find FAX, FAX is my adjacent angle. Okay, so cos of 50 is going to be FAX over FA. But I know FA, I'm trying to find FAX. So FAX is going to be FA times the cos of 50. Now you can work this geometry problem out every time you do this, or you can just remember that if theta, the angle, is stated from the horizontal here, remember this is the horizontal here, if theta is stated from the horizontal, FAX is FA cos theta. So if I want to find the X component, or the horizontal component of the applied force, I will say it's 90, which is my applied force, times the cos of 50, and then I put those numbers into my calculator, and I come out with 57,85 newtons. Remember your units. Okay, now it says calculate the magnitude of the normal force. So now what we should have actually done when we looked at this diagram in the beginning is we should have drawn a free body diagram. So if we draw a little free body diagram, what forces are acting on this box? Okay, they start talking about friction, so we know we're going to have to put friction in, but the first thing we're going to put in here is the weight of the box. So you must call this FG or W for weight. Then you must put in your applied force that's being put on the box there. Okay, the box is on a horizontal surface. The moment we have a horizontal surface, we have the normal force Fn or just N, and because we have friction, we must draw in the friction. Remember, friction opposes motion, so the box is moving to the right, friction is moving to the left, and because the box is moving, it will be kinetic friction. Now this is a lovely force diagram, free body diagram, but it's not actually as helpful as we need it to be, because we want to work with the components of the forces. Okay, so that did not really go straight downwards. Okay, so imagine here is Fg and here is Fn. Why do we need to work with the components of the forces? We need to work with the components of the forces because you may only add forces that are in a straight line. And you may have noticed that Fa is going off at an angle. So we have here Fax, this is the x component or the horizontal component, and we have vertically upwards Fay. If you had a ruler, I'm sure you'd do a much better job than me. Okay, so if we look here, now I've got 3 forces vertically upwards, 3 forces in the vertical plane and 2 forces in the horizontal plane. So when it says to you calculate the magnitude of the normal force is straight upwards. So I need to look at all the forces that are either up or down. Now remember, this box is not flying in the vertical plane. It is remaining, it's doing nothing in the vertical plane, which means that the forces in the vertical plane are also going to be equal to 0 because the box is not accelerating vertically. Okay, it's not accelerating horizontally either because it's moving at a constant velocity. But usually actually the forces in the vertical plane are doing nothing exciting. So if we say that up is positive, okay, every force that goes upwards is positive. So Fn is going upwards, Fay is going upwards. What is going downwards? Fg. Okay, so Fg is going downwards. So because it's going downwards, we're adding the force, but we're adding a negative force. So I'm just going to put it as a minus. Now, what force do we not know here? And we are trying to find the normal. So from this, we will know the normal force will be equal to Fay plus, it's minus Fay plus Fg. Can you see I've just taken them over to the other side of the equal sign, but I don't like it like that because I don't like having my minuses in front. So I'm going to put it so that the positive thing is in front. So it's going to be Fg minus Fay. So now what is Fg? Fg is the code for the weight of the box. Remember, mass and weight are not the same. The box has a mass of 45 kilograms, which we multiply by the acceleration due to gravity. And then we want to take away this y component of the force. So just like we drew this triangle, here is Fay, it is the opposite. So the vertical angle is going to be the force Fa times the sine of the angle. So it's going to be Fa sine 50 degrees. Okay, so if you put this all into your calculator, Fa sine 50, I can't remember what it works out to, but you end up with something like 372,06 newtons if you use your calculator properly. Okay, so now we've found the normal force. Now it says to you, calculate the coefficient of kinetic friction. Now the formula for friction tells you that the force of kinetic friction, Fk, is equal to mu k, the coefficient of kinetic friction, times the normal force. Now handily here we have just worked out the normal force. So this is going to be 372,06 times mu. I'm not going to write the k in because it's just going to get messy. Okay, so that is what the normal is. Mu we're trying to find. But what is the force of kinetic friction? How are we going to work this out? Well, if you have a look at my diagram over here, can you see I only have 2 forces in the horizontal plane? Okay, and if I only have 2 forces in the horizontal plane, and remember my system is in equilibrium, F net equals ma. If you look horizontally, little f minus Fax, because if I say little x is in the positive direction, it's positive. Fax is going the other way, so it's negative. F force of friction minus Fax is equal to 0, okay, because there's no net force on this box. So the x component is equal to Fk. So now luckily, in this part of the question here, I worked out the x component. So this is 57, goodness me, my handwriting. This is 57,85 is going to be equal to 372,06 times m. So by algebra, you can work out mu, the coefficient of friction, is 0,155, which I'm going to round off to 0,16. Now remember, mu, we call it dimensionless. It has no units. Why does it have no units? Because we found it by dividing the normal the force of friction divided by the normal force, and these are measured in newtons, so anything divided by the same thing gives you 1, so a newton divided by a newton is going to give you no unit. So mu has no unit. In physics we say it is dimensionless. Okay, now the last part of the question says, will the coefficient of friction, now look here, they're asking you about the coefficient of friction. They're not asking you about the force of friction, they're asking you about the coefficient. It says, will the coefficient of kinetic friction change if the angle of the applied force is decreased? So they mean, what happens if I do this and make this FA and this angle's teeny tiny? Okay, you know that if you started pulling the box like that, okay, you would actually get the box to go forward faster. So, because you've got more of a horizontal component pulling it along. But the thing is now, the coefficient of kinetic friction has got absolutely nothing to do with the angle of the applied force. The coefficient of friction only depends on, do I have rough concrete over here? Do I have a carpet? Do I have a shiny polished floor? Did I throw some water on it so that a pig could slide on it like a pig on ice? So the coefficient of kinetic friction only depends on the nature of the two surfaces in contact. So the answer to 3.6 will be no, because mu only depends on the nature of the surfaces in contact.